Okay guys, this is going to be a short tutorial and mostly a follow-up on whatever we did until now on VMD and Chimera. So if you remember, we manipulated the structure of RS bound to aspartyl 5' monophosphate, adenosine monophosphate in VMD such that we generate only one subunit out of the two subunits that the original PDB structure had. And then we processed it in Chimera to edit the ligand part of the structure, that's AMO there, so that the molecule AMO was changed to L-aspartic acid, and then we inverted the stereochemistry of L-aspartic acid to D-aspartic acid. But at the end of the Chimera tutorial, we were faced with a problem where the residue IDs and the chain IDs needed to be changed. So the residue ID in this case is AMO, which is a non-standard residue, a non-protein residue. But you see the L-aspartic acid is actually an amino acid, and it belongs to the protein domain. So we need to change that to ASP. That's the standard for standard 3-letter code for an amino acid in a protein for aspartic acid. And also we need to change the chain ID. That's because the L-asp is going to be an independent entity, as it is not covalently bonded to that of the receptor. So it's only undergoing non-covalent interaction at the binding pocket of asp-RS. Therefore, we need a separate ID. So if the chain ID of asp-RS was A, then we need to change the chain ID for L-asp to B. So although it is possible to rename both chain and residues using VMD and Chimera, but it's a bit of a workaround there. So we are going to use a package called PyMol. It's a very powerful package, and it's very simple to do out here. So first of all, you click on the icon of PyMol that you might have on your desktop as a shortcut in Windows. So we click it twice, and then it asks you to buy a paid version, but you really don't need that because the evaluation version is good enough and it has got a lot of capabilities and functionalities. So we're going to skip this activation out here. So the first thing that we'll do is just load up the structure that we have already saved by Chimera in the last session. So what we do is go to File and open the structure, and as you can see, I'm already in workspace 1. So I'm just going to select, let's say, L-asp bound to asp-RS. We also have the D-asp bound to asp-RS that we created by Chimera by changing the by inverting the stereoisomer. So we open the structure, and as you can see, it's loaded already in the new cartoon or the ribbon representation with the ligand that's named AMO out here, but it's actually L-asp being represented as licorice. So that's great. So we don't need to do any kind of change in the representation. So I could show you more about the features of the representation, and PyMol as well, like Chimera and VMD, can create beautiful pictures. But then again, the focus of this tutorial is not the representation. We'll deal with it in some other tutorial. But out here, what we're going to do is we are going to change this name of the residue AMO to ASP and change the chain ID of this particular residue ligand to B, from A to B. So first thing that we got to do is display the sequence. So by doing that, it will be easier. It will be a lot easier for us to go along the sequence and then select a particular region or a particular residue out here. So we go to display and display the sequence, and we see that the 1-letter code of the amino acids in the protein is displayed out here. They are all chain A, and then towards the end you have this AMO that's displayed in the 3-letter code because it's a non-standard residue and it doesn't really have a 1-letter code, or it's not recognized as a protein residue. So, and also change the sequence mode to, let's say, residue names, like the 3-letter codes of this residue, or you could also display the atom names. Okay, so you see the chain identifier here, that's A for all of it, including the ligand. So just for the sake of simplicity, we'll just display it with the residue codes here. And what we're interested in is first changing the residue name AMO to ASP, which we can do by highlighting it first. So you click once on it and the residue here will be selected. So another thing is, if you want to zoom in and zoom out in PyMol, you got to press your right key on the mouse, the right button on your mouse, and then drag along. So if you drag further down, then it will zoom out, and if you drag closer to yourself, it will zoom in further. PyMol has a command line interface as well, just like VMD scripting language and Chimera's command line interface. And so we're going to use this to change the name of the residue. So you see it lists the command input area, get the list of command by hitting tab and everything. So you can do a lot of things with this command line interface and using this PyMol language that they have specifically. I've posted a couple of links on the slide which you can follow for this. So once we have this AMO selected, we can operate on that by using the selected number of atoms by using the cell feature or select feature. The command here is, in order to change the residue name or the chain ID, is alter and then space, beginning of a bracket, and SELE, that's the short form for selection, comma, RESN, that's the short form for residue name, is equal to ASP, and you press enter. So you see the change happening there. It was AMO before and it has changed now to ASP. So we have the desired residue name that we wanted. The next thing that we will do is change the chain ID out here, which we can also achieve by using the same command, alter SELE within brackets, comma, chain is equal to, within quotes, B, chain is equal to B, and then press enter, and you see immediately the change happening here. So the chain is changed to B. So just to be sure, just for the changes to take effect, you got to type another command, that's sort. Once you press that and press enter, you will see that the chains are sorted. So you have chain A here, and at the end the ASP here is chain B. So I can now deselect this ASP by clicking outside the molecule. So once you have made these changes in the residue numbers, residue name and the chain IDs, you can go ahead and save this structure as a separate PDB. So in order to do that, we go to File again and then Export Molecule, this option. When you click on it, it will give you further options to save the structure. Like you want the original atom order, you can click on it and it will retain the order of the atoms that was there in the initial PDB structure that we loaded. And then there's other PDB options like write connect records, which is basically a connection of the covalent bonds that are being formed between different atoms. That's written as an index of the atomic numbers. And then you want to retain atom IDs as well if you want. So this option is important when you're running a simulation after this, because once you have the structure of the complex and you want to run a simulation, let's say with a software, an MD engine called GROMACS, it has certain recognizable capabilities, like it can recognize certain kind of atom IDs or atom types. Basically gonna leave this option unchecked for now. And you also see the segment identifier column that will be written at the end. It's sometimes handy to have a look at the segments at the very end, at the last column that's written in a PDB file. And the header information, if you want, just like in an original PDB file obtained from the protein data bank, you'll have some header information with a description of the structure and the experimental methods and everything else that was used to solve the structure. So you can leave it unchecked as well. So we just found the atomic coordinates here. So we'll go ahead and save it in the same directory, the workspace one, and we give it a different name because we don't want to overwrite this LASP ASPRS that's already written previously. So we give it a name, let's say LASP again, and then ASPRS, and then mod. So underscore mod will identify it as a modified PDB file. And you also want to change the option out here. So this is PDBX and MMCIF. So CIF files are generally crystal structures. It's in the crystal crystallography, the structures that are solved by X-ray crystallography are in the CIF format. But for the moment, you don't want this format of the file, so we'll save it as simple PDB file, and we give it an extension .pdb and click on save. So the file is saved here. So if you want to have a look at it in the text mode, we'll just close this PyMol and then open it with your favorite text editor again. So I'm going to use gvim, so ASPRS mod.pdb. So once you open it, the chain IDs for the protein are retained as A, while if you go further down, scroll down further up to the very end where the ligand is, and you'll find here that the chain ID for the ligand, that's the ASP, that's the amino acid now, is changed to B, as well as the name of the residue is changed to ASP. So we could rename the residue name and the chain ID successfully.